Hi everyone. Are you able to hear me clearly and see my screen clearly? Okay, wonderful. All right. Hi Alvin, April, George, Krishna, Manu, Mohsin, Narendra, Nitesh, Sahasra, Shahida, Samit, Hang, Rahela, Shunes, RS, Tegu, Srini, Sunny, and Vivek. Welcome to the session. Before starting the session, if you have any questions, please feel free to let me know. All right. Just as a backup, if uh, okay, I mean, yes, Hung, yes. Okay, so that is going to be fixed maybe today. Yes, there is a little, switching between the two. So that, so Hung's question is that the quiz was about pig and we haven't really went over it. Yes, basically we have extended a class, one more session. So that's why. Okay, I'll get it fixed. No worries. All right. Okay. Yeah. So if you have questions before starting the session, please feel free to let me know. Um, so Elvin's question is, will we go over home assignment today? So the home assignment so far, we have not given much. So far, what we have given is the quiz in the two sessions, which were self-evaluated. If you have any doubt about the quiz, feel free to ask or feel free to drop us email at support@cloudxlab. Okay. Some of you have reported errors in that. Oh, there was one error reported in one of the quiz. We have fixed that one. Okay. All right, good, good, very good questions. A question from Pradeep. What are other types than the default text input format where we can find these libraries? We will cover this part today or maybe in tomorrow's class. All right. Any other questions before we start? Question from George. Why is it that only 50% is required to pass the quiz? Okay. So we have kept it purposefully that 50% is okay to pass the quiz, but people are free to take this quiz multiple times. Okay. And the agenda with the quiz is that people should be able to, you know, practice again and try it again. It's not really like a university exam. Okay. Therefore, this is mostly for self-learning, and that's why we have kept it that way. All right. Okay. Good. Good. And any other questions at this point? Okay. Okay. So yes, Sudhakar and Rahela, we are trying to address these things, and we are basically updating the quiz section. Okay. We will be informing you very quickly. All right. We are trying to make something like automated assessments, and once we are done with that, we will send all our students again the quiz, and it will be available to you very soon. Okay. Any other questions at this point? Okay. So we will upgrade that, because as far as I remember, we had quite a few quiz in MapReduce. Let me just check. Is the link not active or something like that? Okay. And if not, then I'll just try to fix it. Okay. All right. Any other questions before we start today? No questions? All right. Right. A question from Pradeep is, what is application master and what is the difference with resource manager? Okay. So let me just go over to the questions and manage participants. Yeah. Yeah. Coming back to the question. Okay. We had where is the, yeah, yeah. Okay. So, all right. So you remember this diagram or maybe this diagram? No? All right. All right. So what you see is here, this is the resource manager. Every external client, they first request resource manager for various kinds of workloads. The first request goes to the resource manager. Resource manager negotiates or talks to individual node manager, state governors, and then the head office of the application is established. This head office is called application master. Okay. So per application, there is one resource manager. Are you able to hear my voice? Vikas is not. Vikas, everyone is able to hear. Please, please try to connect again. Krishna's question point is that is application master per request? It depends. It depends. If your application is long running application, then application master will be common for all the requests. Okay. If your application is per session, then your application master will be there as long as the session is open. A client can keep on sending more commands and it'll be the single application master. Okay, like in the case of Spark. The previous one was a case of HBase. All right. Did I answer your question, Pradeep? Great, wonderful, wonderful. All right. So that was a quick recap of a question from Sunesh. If there are more jobs, will App Master be in different nodes. If there are more jobs, if there are more jobs, will app master be in different node? Yes, app master can be on any machine which has container. All right. So app master can be anywhere. And all right, good, good, good. Very good questions. A question from Srini, is it an auto thing or we need to program for it? So while we build an application which runs on Yarn, we can define what kind of application we want. Do we want a long running one? Okay. I think here is, you remember this slide? Okay. There could be three kinds of application masters, right? So we could define our application lifespan while creating an application. But we generally do not create an application for Yarn. Instead, we try to use MapReduce or Spark. Okay. So we generally, the truth is, we generally do not program or work directly with Yarn unless you are really building your application and none of these are fitting into your needs. Okay, none of these are fitting into your needs. Yes, good, great. It was very important to understand Yarn because that's like a pillar of the entire computing. All right, is the recording going on? Yes. Okay, so who else can record? I'll just make you just to keep one more backup. Okay, so I'll just allow you to record. Okay, so Alvin, April, George, although you don't have to do anything, it just in case my recording get corrupted, I can request you. Okay, just to be on the safer side. Yes, I'll just make you allow you to record. If you're going to stick till the end of session, I'll just make you allow you to record. Who can do it quickly? If you're planning to stay till the end, just raise your hand. I'll make you the. Nobody? Okay. All right. So, okay, let me. All right. So where is? Okay. Let me make Sunny as allow record. Okay, Sunny, I have allowed. Okay, I've allowed you to record. You can also start recording. Mohsin, I have also allowed you to record. So both of you can start recording. Good. All right. Yeah, yeah, Ravi. The disk space, hard disk space can be a problem. And yeah. For the people with MacBook Air, there's always this fight for the space. But it's not that big. It's hardly like 300 MB. Okay, good. Now let's start. Today is a very exciting day because we are going to do some hands-on and we'll try our more efforts towards doing the hands-on. Okay. All right. So, although a lot of people had suggested not to have Java MapReduce, so we are not going to get into the Java MapReduce much. Instead, we will just try to run one Java MapReduce program, and that should be good enough. All right. All right. So do not panic because those people who have not studied Java before, generally, I mean, kind of black out seeing a lot of code. But I mean, that's the way Java is. The syntax is a little too heavy, and because of which it looks too complex. For me, it looks easier and familiar because I have coded for like 12 years in Java. Not 12 years, actually 16 years. All right, because since my 2002, I've been working with Java parallelly. Okay, and for me, it may not look complex, but I showed it to couple of people who are non-Java developers. They find it a little complex. So don't worry, I'll try to make it very simple. Okay, so let's try to recollect what we're trying to do. So MapReduce, the framework, does the sorting of the data, but on what basis and what data? That is chosen by you. And how do you choose that? What data to be sorted? By creating key value pairs. So the frameworks gives you certain records, and you convert those records into key value pairs so that these records can be grouped. And then once the grouping is done, the control comes back to you, and there your program is supposed to merge the values for every key. Okay? Remember this discussion we had last time? All right. So yes, so we are going to do that. All right. So why are we talking in Java? Java has primary support, can modify behavior to a very large extent. Also, the Scala, when we talk about Spark and Scala, the code will be written in a kind of similar way. Okay, kind of similar way, and therefore it is not going to harm to have a look at Java code and become little comfortable with it. Okay, so I'll try my best to make it simpler. And all right, so here we are. And all right, so writing MapReduce is in Java. You either have to install Eclipse, then create a Java project, add all these libraries, and go through this whole cycle. Or you could do very simple thing. You could do very simple thing, as in you simply check out the code. Okay, let's just walk through the code, and that'll be easier. Okay, so I'm going to give the repository. So open this repository, and in that, yes, the Android Studio will kind of do because it's under the hood. You don't need, for this class, you don't need Eclipse, honestly. Okay, no need to worry about Eclipse. Okay, so what is Eclipse? Eclipse is basically a very huge kind of text editor in which you write mostly Java code, and it has all the functionalities built in to assist you to code in Java. Okay, yes, you can use the idea or anything. It doesn't matter. And for that matter, we are not going to use any of these IDE. IDE is integrated development environment, and we are going to just use plain text editors. All right. So I mean, are you able to open this GitHub repository? So GitHub is a central place where you can, it's a public open place where you can create your code. And as a developer, to all of you, all of you, you should generally build a good profile about a good profile by creating good project. If you have more stars, more forks, and more people watching you, that means you are popular. Okay, so it's generally a good idea in today's world to have good one or two good GitHub projects, so that it becomes easy for picking up a job, or I mean getting to learn coding. Okay, so in GitHub we have uploaded this project so that our students can go through it and even clone it and modify it as per their needs. Okay, so here it is. In this project, what you see is these are the folders, and this is the README file which contains all of this in Markdown, and this is the build file. A build file basically tells how to compile the code. These are the instructions on how to compile the code. Okay, build files are very common thing in large projects. Okay, build files are common things in large projects. Somewhere we use Maven, somewhere we use Ant, somewhere we use Make, somewhere we use other components for building larger projects. Okay, so if you are into Java development, it is very useful to become comfortable with build.xml. And in case of our Scala programming, we will use a tool called SBT instead of Ant. Okay, all right. Now, this is there are this folder called SRC. It contains the examples of various examples. In this, we have a very simple one where we have word count mapper. Okay, and we have the other code. All right, let me just give you an overview of what we are trying to do. All right. All right, so we are trying to write mapper and reducer, right? As part of this project, we are trying to write our mapper and reducer to count words in our plain text file. Our plain text file contains lines of text, and each line contains words. And we are writing our mapper, which will convert each line into word, comma, one. And then reducer will basically count number of ones for each word. Okay. So the mapper here, what you see is this. Okay. So the mapper here is so it defines four kinds of things. These are the data types. This is the data type of the input key and input value for the mapper. And this is the data type of output key and output value. Okay. So by default, when we are using the text file as the input, the input key is object, which is the how far away is this particular line from the beginning. Okay, so basically that is the key, and the value is the entire line. Okay, so this is the text, and then output is also, this is up to us. This is dictated by these are the data types. Mapper is saying that I consume data which is of this type, and I give out data, the key values of this type. Okay, this is what this definition is. We are defining our class called stub mapper, which is extending a basic class called mapper, meaning stub mapper is a type of a mapper which takes input of this data types, which takes inputs of this data types and give out output of these data types. All right, is it clear to everyone? On this slide, question from Tameka. On this slide, can you add text to add text is determined by the, yes, it is. Okay, so we have byte offset and line input. So Tamika, I did not get that. Yeah, it could be anything else. So this is decided, the input is decided by input format, while output is our choice. Since we want to give out word, which is text, and we want to give a long, which is word one, and so on, right? Which is a number. Therefore, it could be something else. So this part is up to our choice. This part is based on what kind of input data are we trying to handle. Good question, Sunesh. Here, Sunesh's point is the object line number? No. It is the offset, meaning from which byte number, which character is basically character number from the beginning of the file till this line. Okay. So this is the character count. It's basically byte count. Generally, one character means one byte. Okay. All right. Good. So this is how we said that, hey, we want to create a mapper which consumes this kind of data and gives out this kind of data, meaning the data types. Okay. Then we have this function called map. Okay. We have this function called map. Here we are saying that we are overriding the map, meaning we are implementing something which the framework recognizes. When the framework looks at your class, it's going to look for this function called map. And it's going to invoke this function. The framework is going to invoke this function on every input line. Every input line. Here, inside these brackets from here till here, inside these brackets is what we have for our own logic. So in this function, we would get the byte offset, number of characters till this line. Okay, this is the input line. And there is one more thing called context. Okay, so context is kind of a big bag in which we basically put the output. So mapper consumes these two. This is our map function. It's going to consume these two and give out the values into the context, right? How are we consuming? First, we take this value, this second argument, and take out the text out of it by saying value.toString, and then we are splitting it on the basis of space and tab, right? This is a regular expression, which means space or tab and any number of those. So all the spaces, all the white space is represented by this expression. And what does it mean by every line, which is the second argument given to this map function, every line is going to get split based on the white space, which means this array called words will contain the words found in the current line. Okay. Right now, we are not utilizing the byte offset. Sometimes we would like to utilize it based on our circumstances or the problem at hand. Okay. Now, here for strings, like for string words, we are basically iterating over words. Okay. We are iterating over words, and then we are putting the data into context. We are saying context dot write new text word new long writable. Now, why didn't we simply write word comma one? Why didn't we do that? Okay, why we have this text instead of using the basic Java library for string? We Because the basic Java library for string is string, and here we have text. Okay, the reasoning is that when MapReduce guys were working, they realized that the default strings are not suitable for large scale, for a network-oriented application. Therefore, they created kind of a wrapper. It's like a gift wrap. Okay, so while you give out things to Hadoop, okay, while you give out things to Hadoop MapReduce, you wrap your word or wrap your key into their data type, into their own data type. Okay, so we have int writable, long writable, text, and there are various kinds of data types, basically different kind of gift wrappers, right? And when we consume the key value, again, we have to unwrap that gift wrap and then do something and again wrap things. Okay, so in simple words, it's like when you give out and or consume things from the outside world, you generally wrap it and unwrap it. Okay, so this is the only piece of code that we have written, and this is the only piece of code that we basically have done. And mostly these lines, like this is the name of the class, which says that I'm extending this particular class, meaning I am of this type, I am a mapper, and I consume this kind of input data type, and I give out this kind. So here is basically defining what is the name of the class and what is it, what kind of data it consumes and gives out. Okay. And then here, this function is basically a contract saying if you have to write a mapper, you must write a map method in your class, and it should have this same data values here, like object key, text value, whatever data type you have defined. Okay, and you should always give out the same data type which you have defined here: text, long writable, text, long writable. Okay, now going back to your questions. Okay, Sunny is saying why map method takes key and value as parameters. Should not it be taking a certain record? Good question, Sunny. So far what we have learned is that it consumes a record, right? It consumes a record. But it turns out that the mapper also is defined in the same way, and it also gives uh, one extra additional value called key. Okay, the actual record is in the value, and this is the key, and this is sometimes useful, like in this case we are getting the byte count, we can utilize that one. Okay, so this is kind of a global parameter for the whole file, and this is kind of the current record. Okay, so in some way it is useful. Question from Sunesh, if input text is comma delimited, we have to change this code. Yes, we will. Let's say our data is comma separated. So what we'll do is we'll split the data by comma, while we will just keep the usual way, usual new line. Okay. Yes, this line, what you see here is this line. This is basically a line. All right. A question from, so was I able to answer you? Okay, good. Now, Alvin's question is throws error handling? Yes, very good. Very good to notice that. So here we are saying that our data, this function throws these kind of exceptions. Instead of us handling it, we have just thrown it away to somebody who is going to handle it. Ideally, we should tackle our own errors here. Okay. Ideally, we should tackle our own errors and solve it. Okay. Rahila is saying here mapping and reducing is done to the entire input, selecting this. So there is no reducing happening here. Okay. It's only the mapping that's happening. But yeah, thank you. Okay. Yes. Question from Ravi. What does long writable instruct? Long writable is basically a wrapper on top of long. Long is a huge number. Okay. Long represents a huge number. So does long writable. And long writable is Hadoop's class, which is a kind of wrapper on top of long. Okay, it's a huge box in which you can put numbers. And Manu's question is, value means one line? Yes, value means a single line. All right. A question from Rahela. Yes, good. Thank you, Rahela. And a question from Ravi. Could it be better to combine comma separated and space in one piece of code if that is how data can be? Yes, it all depends on your own data. Okay, so if your data is say comma separated, so you will basically write here, you will try to split it on comma separated, but there could be, the input could be of many kinds. We will discuss on a later point of time. What if your individual line is a JSON record? Right? Your individual record could also be JSON, right? In those cases, you can still use the plain text way of handling things. And here, instead of splitting the data, you parse individual line text, and convert that into a JSON object. And then you can do whatever you want. All right. So this is where your creativity and your engineering skills are required, where you handle your data in whatever format it is given and solve the problems. Okay. A question from the makeup. What if there is more than one delimiter? It is up to you to tackle it in your way. Okay. So there is only one for loop in this. Here, the second brackets are closing map function, and the third bracket is closing the class. Okay. 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 A question from Manu. Key means what? I did not get. All right. So ideally, the text should have been sufficient for us. This should have been sufficient for us. Okay. Because this is the individual line. This is the line which we are given. And this is extra information Hadoop is giving us. In the form of key, it's saying that this line starts at this byte count. Okay. This line starts at this byte count. Did it make sense, Manu? Okay. All right. Good, good. I hope I've answered your questions. If not, can you just paste it again? I'll love to answer your questions. All right. So this is how we define mappers. I know that you, if you're not from Java background, this might look intimidating, but do not worry. It's a similar structure followed in everywhere. Even in Scala or even in other languages, we generally define a class following a contract. Here we are saying that we abide by a contract called mapper. We will define a function called map with this kind of arguments, so that framework can call this function with the for the current line. So the way framework will do is framework will create an object from this class. This is the blueprint. This is the blueprint of your Java class. Framework will create an object out of it. Okay, and that object of this class will be executed against will from that object. So for every input split for the entire data on one node, it will be instantiated only once, meaning the object of this class will be created only once. What does it mean by creating object class? Converting this code into something that can reside in memory, something that can do something. Okay, so that's a kind of my way of defining a class. So an object's map method is what the framework is going to call again and again on every record. So this method is going to be called again and again on every record of the input data. While this class is going to be instantiated only once. Okay, so question from Vivek: key contains only one byte count, or is it specific? So this byte count is from which character number is this particular line starting. Remember, this map method is going to be called on every line, so every time it's going to be different because every line starts at a different character number, right? No? So for example, let's imagine that this is your text file. Okay, this is your first line. Okay, in this first line, I'm just saying that this, let's say this is a text file. The first line is starting at 0 byte count. Second line is starting at the total number of characters in the first line plus, yeah, total number of characters in the first line. And third line is starting from the total number of characters in first line plus total of number of characters in second line. So that's the byte count for the second line. Okay. All right, RS was able to answer your question. So there is another class which is calling mapper for each record. That class is MapReduce framework. Okay, that class is MapReduce framework. Good. So MapReduce framework is basically creating an object of this class and calling this object on every record. And this is happening on many machines at the same time. Okay. A question, yeah, question from Ravi. What does override do? What does override do? See this function called override. What does it do? It basically says that this method called map overrides the method defined in the mapper, which means that when somebody calls map method on this, it executes this one, not the parent one. Okay, in other words, whenever we are implementing a mapper, whenever we are saying that, hey, we are creating a mapper, okay, we have to write override. All right. Vivek's question is, key can have other info also other than byte count. Yes. Good point. So yes, this key and the value can have other info and are dependent on which input split we are going to use. Oh, sorry, which input format we are going to use. Okay. It is a function of which input format we are going to use. And right now, by default, we are going to use text input format. All right. So each can have different information than the byte count depending on which input format are we using. Okay, input format converts the data block from HDFS into this key and value. Okay, this is the input record containing key and the value. All right. I did not want to make things complex earlier. That's why we had said only the input record. There was a question from Tegu. The map function output is key value. Why the method is void? That method does not return a value or just modify. Wow, that's a good question, Tegu. All right. Can anybody answer this question? This map method is supposed to give out key and value, right? Of this data type, what we have defined earlier, right? But it returns void. It returns, a method is supposed to consume something. Method is, it consumes this data and give out this value, right? It can give out the value. So but here we are not giving the void. Can anybody give the reasoning? I'll give. All right. Here, instead of returning value, we are putting the output in this object called context. The bucket that came in the argument, this is the bucket. I mean, you can say it's a kind of box or a bucket that was handed over to you by MapReduce framework and said that whatever you do, put your output in this bucket. Okay? You, whatever you do, put your output in this bucket. And that's what we are saying. Context dot write. We are writing into this bucket or this box. We are putting our output into this box. Okay? Now, why not return there? Why this kind of construct? The quick reasoning is one, one, since our program is going to give out many values, not one key value. Our map function could give out hundreds of key value. One single map function can convert one record into many key values, not a single key value. Therefore, if it was just returning a list of key values here, the framework will have to wait till the map function finishes creating key value pairs. Okay, did I answer your question? All right. Yes. A question from Sunny. The result is stored in the context, so we can get the value from the context. Yes. The result is stored in the context. That's right. Thank you, Sunny. Vivek's point is, can I extend mapper where question can be implemented class? Okay. Can I extend mapper? Yes, you can definitely extend mapper. And question, yes, you can do that. This is generics, or you can say templates. Generics in C++ and templates in Java. We can do that. All right. A question from Manu is, yes, thank you, Manu. Okay. And all right. Yes, thank you, Rahela. That's right. Okay, a good question from Pradeep. Yeah, Pradeep's question is this. So is it capital C or small c? Answer is small c, because here this context represents data type. Okay, text represents data type, object represents data type, while this is the name of the variable. Key is the data type of has the data object. Values data type is text. Context's data type is capital C context, and therefore we always do operations on the objects. We define an object with a data type, but we operate on an object. Good question. So question from Sunny is, where did we instantiate context? We did not. Framework instantiated it and handed over to you. This context is going to be used in across. It is a shared object from the map Hadoop side, so that it can gather all the key values from all the records parallelly. Okay, so context is the one which is gathering the data from all mappers, all map functions being executed on the same virtual machine. Okay, so we don't instantiate it. It was created, this object, these three objects are created by the map framework and handed over to you, while will be handed over to you when this map function is executed. Yes, thank you, Tamika. If you want to parse JSON data, here's the link. So here, if your value is a complete JSON object, you can do the parsing of JSON object here. Okay. A question from Sunny, do we write a configuration to it? Not much, but we can retrieve configuration from it. Okay. Question from Ravi, what is JSON file again? JSON is JavaScript object notation. right? In case of comma separated values, we can only represent very simplified data, which is of tabular format. If your data is very complex, objects inside objects and values inside values, comma separate values inside another array of values. So in those kind of complex data, you generally define JSON, okay? And whenever there's a complex data, you basically have to either use JSON or some XML or some other complex format. Okay. Can you explain once again why the parameter is key and value again? Is the input of map function key and yes, that's right. Input of the map function. So when we said input record, right? We said input record. Input record was made up of two things: key and value. Okay. And the mapper basically consumes the input record, gives out many key values. Okay. So that's the way it is. Did it make sense to you, Teku? So yes. So input record was basically a composite object having key and value. All right. Shall we have a line of source data and output? Sure, sure. We'll show you this part. Yeah, so what it is doing is, thank you for this suggestion, Krishna. Let me try to show you. Let's say we have, this is a line, right? So this code, this piece of code will convert it into, quickly, this one is A1, and line 1. Okay, so it's going to say context dot write and new text like this. Okay, this is what it's going to do under the hood. I'm just talking like Java programmers, making you feel a little awkward in this way. Yes, so this is what it's going to do for each line. If there is another line, it's going to, so similarly for all of these, it's going to do. For every word, this one, is one, A1, line 1, the same thing is going to happen. Okay, then, so, all right. Also, in other words, right, if you have two lines, this is a cow and happy birthday, right? So the map function will be executed on this, okay? Map function will be called with this as the text, okay? This is the text, your map function, whatever you had defined, okay? And this, for the second line also, the map function will be called in the same way, just that the, how many characters are these? These are 12 characters, so it'll be 12. Okay, so here context will be passed. Does it make sense to you? A question from Sunne is, this function is only for structured or semi-structured data and not for, it is for both. So the unstructured data is how you are going to convert the input data into record, right? Input split. That's done by input format. We'll talk about input format soon. Okay, so a MapReduce can handle all kinds of data, whether structured, semi-structured, or unstructured. Krishna's question is, this example is happening default in Hadoop without writing this function. No. So this part is happening by us. This call, this method call is happening by Hadoop. Okay. It's just that this method is defined by us. Okay. Did I make sense to you, Krishna? Yeah. So these are the two lines, right? First line is starting at which character number? 0, right? And second line is starting at which character number? Up to here is how many characters? 12, right? 12, and then the new line. That means 13, and 13 means 12 if we are starting at 0. Okay. No, you don't need to call. Yes, that's a very good point, Manu. You don't need to call this map method. Framework is going to call it. Okay, we are just going to hand over on a silver platter these two classes to Hadoop, saying here is my mapper, here is my reducer, and please execute it whenever you encounter a record. Here is my input data. Okay, here's my input data. Here is my mapper. Here is my reducer. Please execute these things on this input data. Okay, and this is the input format we are going to use. A question from Krishna. We are overriding the public existing method. What should that be? What should be in that method before override? I think that's an abstract class. Okay, it does probably this map method does nothing. Okay, a question from RS. So in general, we will only create the map logic based on our requirements. Do we need to do anything else while mapping? No. We basically need to consume the key value. Based on our logic, we will convert these key values into these input key values into output key values. And we also may choose not to give out any output. It is up to us to whether give any, many, or none key values. Okay? Yes, thank you, Kar. Those, yes, we need to import various Java classes. We will put those Java classes. I will show you the exact code and you will have clarity. Okay? Okay. So 0 and 12 are the line, the character count, the byte count. Since this line is starting in the beginning, so we're talking about a file which has these two records. Okay, which has these two records. Okay, these two. So this line is starting at 0. So this is the number of characters, and this is the argument. And 12 is the the count from here. Right? This is 12 plus new line, and that's 13, and therefore it's 12 because it begins with 0. Therefore, 13 means 12 in the index. Ravi? It's a number of characters from the beginning of the files. Okay? From the beginning of the file, it's the number of characters. So your map function is going to be called on every line in this case. Okay, because each line is our record. So there is no guarantee. So remember this, maybe this map method is being executed on one machine. This map method might be executed on another machine because this file could be this line, this file could be on many machines. First line being on one machine, second line being on another machine, right? Therefore, this is our hope to keep a track of which line we are processing or where we are in the data. Okay. Okay. So the next position is not automatically counted if we want it that way. Next position is not automatically counted. So it's framework is counting it for you. Okay, framework is giving out this. All right, the input format is giving out this. So for each line, your map method is going to be evoked or invoked. Your map method is going to be invoked for every line in the input text with the with the line, each line as the argument, and the character count at which this line starts. Okay. All right. So that was Ravi's question. Manu's point is, in map, we are passing one line from the record. How does how the iteration of online is all lines are happening and where we are passing whole record. So whole record here means a single line. Okay. Whole record means a single line combined with a byte count, right? Now, question is, where is the iteration happening? The iteration is happening in the MapReduce framework side. Hadoop is doing it for you. Hadoop is basically picking up the data, converting it into input record by the way of input format, and then for every line or for every record, it's calling your function. So you don't have to iterate over the records. You just have to convert this input record into something you wish to. Okay? Did it make sense to you? Yes, I'll show you where are we passing the whole file. So once we are done with writing the mapper, the reducer, then we'll stitch the whole thing and then submit the job. Okay, so we're going to do that. All right. Now a question from Tegu. So basically, we can override the map method based on our need. Yes, exactly. We have to override this map method. RS is saying, can we also do some EL programming using MapReduce instead of mapper and reducer? I did not get this. //EL parallel programming using MapReduce. So no, actually, this MapReduce framework is fairly restrictive. It basically gives you only these 3-4 controls: mapper, reducer, combiner, and partitioner, and input format. These are the only controls it gives you. You hand over the writing these things and hand over it to framework. You really cannot do anything beyond these things. Okay, so parallel, every kind of parallelism you have to emulate by the way of utilizing the framework. Okay, lots of tasks can be converted into MapReduce in this manner, and some of the tasks cannot be. Okay, good, good. So this is where we are right now. All right. So generally, it becomes a little tricky when we are creating MapReduce, and you will see that. I'll show you something interesting. Okay, so I had to how many of you know there is something called matrix multiplications? So if you have to multiply really huge matrix with each other, okay, in those cases, how would you utilize MapReduce framework? I had written it a little while back. I'll just give you the link so that you can take a look at it. So all I'm trying to convey here is, with MapReduce framework, you can actually do a lot of things. Okay, where is the okay? Yes, this is the one which I had written. So those who are not aware about linear algebra, they'll find it a little hard in the beginning. Okay, so never mind. So I've just given you an idea that a lot of things could be done using. Where is this line coming from? right, a question from Tegu. Sorry, I missed your explanation. So where we call this map function in your program? We don't call this map function. Okay, we just hand over this class to Hadoop, and Hadoop will call it. Okay, Hadoop will convert the input data into records, which is the composite of these two, and then for every record, it's going to call our method. Okay, we don't call it. We just hand it over to Hadoop and say that this is my mapper. Please execute whenever you wish. All right. Okay. In the similar way, we create another method. In the similar way, we create another method called reducer. Okay. This is the name of our class. You can name it Sandeep Giri reducer or whatever, and then extend a base class called reducer. Okay, what does it mean again? It means we are saying, I'm trying to create this class which is extending, which is basically a reducer. This is of this data type, and having this as the input key. Remember, this should be same as your mapper. Why? Because the output of mapper is going to come to reducer, right? So the key and the value input is decided by the mapper here, and we give out the key and value out of reducer. Okay, now what is it that we are trying to do here? Same way, we are defining a reduce function which is going to be called by the framework. Once it has done grouping the data, it's going to call our reduce function. And what is it it is going to give us? It's going to give us the key and the list of values. Iterable means a cursor. Cursor, if you're coming from database background, you can see what does it mean by cursor, or you can always think of it like a huge list of values. Okay, so once framework has collected the output of our mapper function, it'll group it, and it'll group the data based on the key, and all the values will be for every key, all the values will be brought together, and for this group our function will be called. If there are a million keys, this function will be called a million times. If there are a billion keys in the input data, mapper function will be called a billion times. Okay, if there are a million unique keys, right? For each unique key, all the values will be grouped together. Okay. And again, in the same spirit, it also hands over a context object. In this, we are going to write our output. Okay. So what is it that we are trying to do here? We are iterating over the list of values which we are given, and we are summing up the values. We start with sum equals 0, iterate over the values, and keep on summing up. So our function is being invoked by the Hadoop framework for every key and values, for every key and value group. Make sense? Is everyone with me on this? Okay. Okay. I mean, if I had to write it in, say, a very simple way, like I'll give you a very good example of, say, if I have to write it in Python, it'll look like this. Define reduce. Okay. It has got a key, values. Okay. And then we got context. That's all. Okay. Here we write our method in which we say, sum equals 0 for value in values, sum plus equals value, and context dot write key comma sum. This is what we're trying to do. This is the objective of this function. Yeah. It's very simple. And if you ask me about the map function, in the map function also we were doing similar thing, very similar thing. Okay. Here we were saying map function. Here we can say char count. Okay, char count is what we're getting in the input, and line is what we're getting in the input. And we were saying for word in line dot split. Okay, and we'll say context dot write and word comma 1. This is what we were doing in case of mapper, right? Does it look clear? This is Python code. Okay, so after this we are going to discuss Spark sorry, Hadoop streaming. That's going to be far more simple. Okay, all right, there are a few questions I have missed. Okay. All right. Ravi is saying, is a Google search one example of use case of MapReduce? Ravi, no. In case of Google search, basically there are many things involved in that. In Google search, when you click on search, it basically looks up in the indexes and in the index, and then it gives the result. The example of MapReduce is in the one part of the search. Let's say there is this, so let's say Google has to download millions of records from across the globe. Sorry, millions of websites, right? For the search, Google keeps on crawling, keeps on downloading all the websites and keep on pushing it into their database, right? There, it's happening using MapReduce. In the mapper, they're downloading websites parallelly and then parsing it and then pushing from every mapper into the database. Okay. In our case, when we were trying to churn the plain text file of the logs to give the analytics on the user, our input data was the Apache Web Servers log, and we were doing that. All right. Okay. Yes, thank you, Manu. So for each key value pairs, reduce will be called. Okay. Okay, going back to this code. So you can see that Python code is really, really simple, and the Java code is a little complex. Okay. All right. So when the MapReduce framework can perform group by key before calling reducer, then why not a count or group by? Okay. So the logic, whether to do count, whether to do sum, whether to do something like average, or whether to do max, whether to do min, that's something dependent on our business logic. And that's what we define inside reduce function. Did it make sense to you? Or did I understand your question correctly? A question from Pradeep. Once all the key value pairs are sorted and merged, then the reducer will be called. Yes, reducer, our reduce function will be called on every key and value, every key and values. All right. Yes, sorted. Sorted, merged, and grouped. Pradeep, there is one word that we have left: sorted, merged, and grouped. Okay. And for every group, our reducer is going to get called. A question from Tegu. So in MapReduce, we just define the function with Java or Python and let the Hadoop handle that. Yes, yes. So this entire process of sorting, grouping, writing to the output, in the entire process, most of the workload is taken care by Hadoop MapReduce. We are just given these small uh, customizations that we are doing by the way of providing our mapper and reducers. Okay, good. This is a good way to look at it. All right. So once we are done with writing, I'll come back to the limitations, Kar. Once we are done with writing mapper and reducers, and once we are done with both the parts, then we define something called a job. Job is like saying that I am applying for my MapReduce job to be executed by the framework. Okay, so we say that let's name my job as word count, and I'm saying that my class name is this, so that in logs the name should be displayed like this, and my mapper class name is this. Remember, this is the class which we created, and this is my reducer class. And then here I am also defining some more things like what is our output keys data type, output values data type, and the map outputs data type. Some of these are optional. Okay, then we are saying that this is our file input, right? So what all we have defined so far, we have defined that this is our mapper, this is our reducer, and the data types of input key and output key value. And we are saying that we are saying here we are saying file input format dot add input path. Okay, what does it mean? We are saying in this job, please add this as the input file. In this job, please add the second argument to this program as the output. So whatever argument you pass as the first argument will be considered as the input data, and whatever arguments you're going to give to this program, as second argument, that will become the output folder. So while executing this step driver, we have to give input file as the first argument and output file as the second argument. Also, please note that always giving this output is always a folder, and this folder should not exist upfront. Okay, input is a folder. Can be a folder or a single file. Output is always a folder that does not exist right now. Okay, otherwise it will give an error. Once we are done with defining our job this way, what all we define mapper, reducer, and we defined the input file, output path, and once we are done this, we are saying job.wait for completion, and here. So we are waiting for the completion of this job. Okay. Once the job finishes, then we exit. Good, everyone? All right. So general way is once we have defined in Eclipse, we export the jar and execute this. So instead, we will just follow what is there on the website. Okay. I want everyone to give it a try with me. Okay, even if you never studied Java and you have no background in Java, still, I would like everyone to give it a try. Okay, so log in into your web console. Are you able to open this website? Yes, all of you. Okay, so here we are going to execute my.stepdriver. So what all we are going to do, we're going to check out the code. Okay, check out the code as in we will from the github.com, we will download it into our own console. Okay, so Ravi, did you see my chat message above? This is the GitHub. Are you open the GitHub? Are you able to able to open the GitHub? So here, first we are going to clone the repository in our home directory in CloudX Lab. Then we'll go into this folder. And once we are done that, then we are going to run ant-jar. Okay. This will compile our code. And once we are done with that, we are going to execute this. Here we are saying that this is my bundle of code. What is jar? Jar is nothing but a bundle of code. When we run ant jar, it's going to compile our MR examples and bundle everything into a file called mr.jar. Okay, we have defined ant basically picks up build.xml. In build.xml, we have defined that if somebody tries to call ant jar, it is going to create mr.jar as the output after compiling everything. Okay, so we're going to say Hadoop jar, and then we are going to say mr.jar, and this is the name of our driver. Now let's take a look at our driver. So inside src, inside my, and here is a very simplified driver. Okay, it is little more more number of lines as compared to what we had in slides. Okay, and there is a mistake in this, and this is wrong. Okay, yeah. Anyway, let's try to execute it. If it gives error, we'll think about it then. Okay. All right. So yes, a question from Mohsin is: would people need Java underscore home setup in class path for this chart to execute? Not really. Not really. Okay, Java home is already set properly, probably. If it is not, then we will set it up. Okay. All right. So are you going to do with me? All right. So open the web console, all of you. Are you opening the web console? I should also open the web console. All right. So I'm going to open the web console. First, I'll go to my lab, and then we'll open the web console. Where is my web console? Here in the lab credentials. In the lab credentials, I see web console. Ouch. Okay, I did not work like this, and then this. All right. Is the font visible to you? Okay, so thank you, Sunny. So you can actually clone the project and have your own GitHub repository of the same thing in which you have Maven one. Okay, I can merge your output. Okay, all right, that's a good thing. All right, so here we are. Everybody logged in. I'm going to delete my old examples here. All right, so Alvin, April, George, Jiankun, Kar, Krishna, Manu, Mohit, Mohsin, Narendra, Nitesh, Ravi, Roger, Sudhakar, Sahida, Samit, Shruti, Hang, Pradeep, Rahila, Shunesh, Veera, RS, Tameka, Tegu, Srini, Sunny, Vikas, and Vivek. It is saying for Roger, it's saying Roger, can you just quickly give me your ID? By the time everybody is logging in, I can quickly fix your account. Okay. Yes, this is the one. Okay. Let me just change it to, how come it's January 30? Okay, let me just change the end date to something. So 15th April. Now you should be able to see. Anybody else is facing the problem with respect to? That's a login. Okay. Are you able to log in? Mohit, could you message me your email ID? So I'll just fix it. Okay. All right. Let me just April 15.
Sandeep?
Yes.
Hi. Yeah, I'm currently able to log in. Thanks. So you're saying once you're logged in, just go to the web console, right?
Yes. Yes. That's right.
Thank you.
All right. Great. Great. Anybody else facing the problem? Okay. So there we are. And let me minimize it or send it to somewhere else. All right. Where were we? We were on this page. Okay. So let me also start cloning and okay. Yes. So I have git clone and given the repository. Okay. Yes. Thank you, Hank. Okay, so Manu's question is interesting. So in the code, we have defined argument 0, argument 1. Where are we passing these arguments? You see the last command? See the last command? This is the first argument. You see, this is the input folder, and this is the output folder. All right. So this is our driver. Driver takes first argument, this one, second argument, this one, and driver is executed with Hadoop jar. Okay, so Hadoop gives us this command called Hadoop, which has two functions. One is fs, we have studied fs, and jar is the way to execute MapReduce. Fs was to execute the file system commands, and then jar expects us to give us the bundle of the code, and then give us it expects us to give MapReduce. The second first argument is the name of the entry point. This is our entry point or the driver which ties things together, and this driver expects these arguments. Okay, this driver is our code. In our code, instead of hard coding, we have written take first argument, second argument. So Java MROut should not exist before you start the process. While this is our common data folder, this is going to be created in your home directory. Okay, this is going to be created in your home directory. This is the input folder which is common for all, like /data/mr is the place where we keeping all the data. /data is the place in HDFS. Both are going to be in HDFS. So once your process finishes, you will see these things in the Hue or Hadoop FS. All right, let's try it. Okay, so we have cloned our directory. Then we are going into MR examples. Okay, here we are going to say ant jar. Okay, let's just wait for it to complete. It says build successful, and it has built this. Good. So it is saying that it has picked up this particular build file, meaning all the instructions about compiling, bundling, it will pick from this. file, and then it is starting Java compilation. It's giving all kinds of information, and then it is bundling it. Okay, so now we are able to create jar. Now let's execute our jar file. We have to provide Hadoop jar is the command provided by Hadoop MapReduce. Essentially, it's a client for Hadoop MapReduce which submits the job to Hadoop. Okay, it expects us that the first argument should be the bundle of code. Okay, and so this bundle of code is like zip file. Bundle of code is like zip file. In case, just a very good tip for all of you. In case you, so I'm referring to things in a relative manner. Okay, so you can actually say from here till here, or you can from the current folder, which is MR example for me. I'm using this. So here it's saying that it's a zip archive. Do you see that? It's a zip archive, and with this version number. So it's nothing but like a zip folder of all the code. Okay. File is a Unix command which can actually tell what is there inside the data. Okay. All right. So here we go. Now I'm going to execute this. So here our code is, if we do not start our folder name or file name with the slash, that means it's going to be relative to our home folder in HDFS. If we start with the slash, it's going to look from the absolute location, and that's how it is. If we had forgotten, let's say we had just put our x.txt, it will try to find that x.txt in your home folder in HDFS. Okay. So it says that output directory already exists. If you're getting this error, right? If you try to execute multiple times, you will get this error. Okay. Right? Output directory already exists. You can delete the output directory by either using Hue or using Hadoop FS RMR. Okay. So if the output directory already exists, we'll give this error. Or no, you don't have option to overwrite it. Okay. So or you can just in this command you can give some other folder. Okay. So it is saying some error to us. Let me just see what error are we getting. It says that I have consumed 4 GB of disk space and my quota is 4.8 GB. Ouch. Okay. So what to do after changing directory, Rahela? You just have to say ant jar to compile that and then execute this command. All right. Let me see if I can clear up some space, and maybe I'll request some more data in my home folder. Okay, let me open Hue. Okay, for Sunny, it was successful. You can take a look in Hue, the output folder. Okay, let me just delete the entire thing. Maybe that'll solve some things. Can I? Yeah, I think I can delete all of this. That'll make a lot of space for me. Yeah, this can be deleted. This can be deleted. This can be deleted. Okay. Yeah, this is good. I think that'll make enough space for us. Good. All right. So yes, that's pretty much. So Sahida, you can go to your home folder in Hive. Here, Java out will be made, and that you can delete. Okay, so we can delete this one as well from my trash. Okay, you can say empty trash. That's it. I'm emptying because my home drive is full. and nobody, we have put this restriction that nobody will be allowed to have more than 4 GB. Okay, so let's see if I get some more space. No, ouch, this is not happening. All right, what can I delete? I think I can delete entire thing. So the other cool way is Hadoop fs minus du, and not like this. Mm, so du basically shows you the disk space of all the numbers, all the things. So we have quite a few data. Du minus s. H. So I'm trying to see the disk usage. Okay, so this is my HDFS. Move HDFS to HDFS.txt. It's good that this happened. Maybe you will also get a little more familiar. So I'm using this nice command called du minus s minus h to compute the file sizes in the disk. And now I'm using a sort command to sort. Okay, so here we are. And oh, it doesn't have that way. Cat HDFS, and then I say sort minus nr, and you can see that these are the biggest files here. One is Spark's sentiment files. I'll just delete sentiment files. That'll make a lot of space for me. Okay, so yes, let me go back to my home folder. Here's my home folder. And I'm going to delete, say, songs word count, TMP, sentiment files. Okay, so I could actually utilize, so this is what it is. All right. I could say replace new line with this and Hadoop fs minus RMR. So I'm going to delete the sentiment files, Spark staging. Let the Spark staging be there. Should I delete it? Okay, songs word count, temp, hive jars, data, myml. I don't need all of this. Okay, I already have this data. So I'm deleting some of my data so that I can get some space. All right. So I'm doing it purposefully. Okay. So somebody's muted and I can hear the echo. All right. All right. Good. So it's good that this happened so that you also get a flavor of handling with. Okay, no worries, Saida. All right. So here we discussed about our let me also try again. I hope this time I'm able to run it. Okay, let me go back again. So why I was trying to do all of this is because my quota in HDFS is full. That's why I'm trying to empty some of the files. So we used a command called du, and from the du we found out what were the top directories which took maximum space, and then we tried to remove and empty the trash. Now this seems to work. All right. Why did it give error upfront? Because it's mr.jar and all of this, it tries to create, when hadoop.jar starts, it tries to create an output folder. So it has created this output folder. Let me also show you parallelly. If you go into file browser, go to your home directory, and then you order the data based on the date. Okay. And there you will see this. Do you see this? All right. So yeah, sure. Question from Ravi is that can you share the Unix command? Definitely. So here what you see is it shows the mapper. It was executing Hadoop. See, so reducer only started after mapper submitted successfully, and then it started reducers. And then by default, since we have not explicitly mentioned anywhere the number of reducers, so there would be multiple reduce tasks. Just a second. Yeah. All right. So let me first give out the command which I was giving. Okay, history minus say 30. Okay, so these were the commands I was trying to execute. All right, you see, mm, these are the commands that I tried to execute for. Okay, all right. Okay, so these are the commands. Never mind. So those who are not interested in this, they can simply ignore this. What's wrong with this? Is it not allowed to paste a really big question? Okay. What's wrong with this? Just a second. I'm wondering what's happening here. No, it's not giving the focus back, actually. That's one of the reasons. Let me just try again. Am I not host or something? I am host. The focus is something wrong with this. Okay, I think this time it went through. All right, this time it went through. I hope it continues to. Yes, it is working. All right, never mind. So, sorry for the distraction. Coming back to what we were doing. So, we were able to run our MapReduce command. This was our command. History is one command with which you can execute. You can see what all have you done. Okay, so once our student gets stuck, we generally take a look at the history and then try to see where what all they're doing wrong. Okay, okay, so yeah, and all right, now where we are able to execute this particular program. It contains all our code containing mapper, reducer, driver, and every other thing. Second is the step driver. This is the file name of our class, the name of the driver class, which we have written, which is the entry point. And then this is the input data, and this is the output data. Okay. And let's just take a look at what we were doing. Let's take a look at this folder. You see, it has created this folder called Java MR out. In this folder, what you see is there is a file called part R001. There is single reducer. If there are multiple reducer, keep on increasing their names. And part R means it is created by reducer. Had there been no reducer and there was only mappers in the game, then this instead of R, it will be M. Okay. Now you can see that it has generated the word count. The only problem is it has not removed these special characters. Therefore, you can see the don't has come multiple times. Yes. So we can in our Java code of mapper, we can clean up the strings, convert it to lowercase, and then we will get the good result. All right. All we have to just change. All we have to just change the. Okay. A question from Sunesh: can we align the results? We can't. We cannot. All right. Okay. Because this is being done by input format. So either we modify the input format, and only then it'll happen. Yes. Question from Srini is: does the input path exist? Let me show you. Let me show you. It's so we are talking about what is the input path? This is our input path. Okay. This is our input path. Let's go there. It says this is the top level. Okay. Slash data means it means go to slash at the top level, then go into data, then go into MR, then go into word count. Okay, remember that. So this means go into data, go into data, go into MR, go into word count, and then input. Okay, let me show you where is it. We went to top level folder, okay, by clicking on slash, then the data, then we went to MR, then word count, and then input, and then there we are. This is the file. So if there were multiple files in this folder, they will all be combined together and the result will be treated as if it's a single file. Okay. I missed one question. There was a question from George. Okay. Saida, are you able to see this? I think she has logged out. Okay. Saida is logged out. Okay. All right. So George is saying that I don't see these files in Hue. What you have to do is click on if you as you log in, right? You will be in your home folder. It'll be like slash user slash mk something your login ID. You click on the top level slash. That means you are going to the top level directory, and then the data folder, and uh, then inside this, what was it? MR. There is MR folder, and then what counts. So this is the input data that we're talking about. All right, Roger.
Yes, Sandeep, I'm still unable to see it.
Okay, can I take a look at your screen?
Sure.
I'm stopping to share. Yeah.
I'm sharing right now. All right, so I'm right here. If you can see my screen.
Not yet. Not yet.
I'm sharing screen.
Okay, please.
Sure. Okay.
All right. Yes.
So I just ran the job, right?
Okay. Can you
Right.
show me? Can you show me the console?
Oh, firm. Okay. Yeah.
So go up, go up. Yes, it has successfully completed.
Yep.
Okay, good, good. You come down. Let me take a look at your command. You
Sure.
have executed this command. That means, so you are consuming slash data slash mr, same place what we consumed, and then
Right.
writing to java mr out. Okay, let's take a look at your home directory.
Okay. So we go back to the U, right?
So you go to file browser first. File browser, third tab from the right top. You
Okay.
see, this is where this is the file folder structure.
Okay. So this is where I'll be able to go through here.
Yes, yes.
Okay.
Okay.
No problem. All right. Thank you.
And yeah, input directory, are you able to go to?
I should be able to. I'll follow the directory which you mentioned.
Yeah, click on the slash and then you can, yeah. Yeah, here, if you click on data and then MR, click on the data, the fourth one. Yes, go down. So this contains almost all kinds of data that you might want to take a look at. And
Okay.
this is the folder. If you get lost anywhere, just click on the home folder.
Which will be here.
Just before this, before there's a home, HOME. Yeah. So this is your own workspace. All right.
Okay.
So
Got it.
when you don't give absolute location, this is the folder that gets treated. All right, great, wonderful. Now, yeah. So anybody else stuck? Yes. I was seeing there was one more. Uh, Roger, are you able to get it done? George or Roger? George, got it. All right, great. Okay, actually, I forgot which. Okay, good, good. So great. And there are quite a few questions I could not go through everything. So Sunny, are you able to execute Hadoop jar, MapReduce jar, MyStub? Okay. Okay. What error are you getting, Sunny? And Srini, unable to go to path. Srini, you want me to take a look? Okay. I'm starting to share. You can share your screen. Okay. So I think okay. By the time we finish one or two sessions like this, everybody's problems would be solved. Okay. Srini, you can share your screen. Yeah. Okay. So, all right. So this is your home directory. This is not the HDFS. We have to, so right now in the top level directory, okay, you can say CD enter, CD enter, PWD. Now this is your home directory. This is where did you check out? Show me ls here at this location. Yes, this is where you checked out. Go to MR example. Oh, you're looking for the data. Then you have to take a look into the HDFS. Okay, so you'll have to, yeah, yes, this is where it is. So this is in Hadoop HDFS, and there, that's a local machine. Okay, these two are different file systems. Okay, so if you want to take a look at, you can say Hadoop FS space minus ls, yeah, enter. You can see. All right, wonderful. Any other questions? Okay, Sunny, do you want to share or should we take a break? All right, let's take a break and throwing error file not found this. Whereas I don't have. Okay, let's try after the break. I think we are already. Whenever we try to do something extra, it takes more time. All right. Break for 10 minutes. Back by 10:05 p.m. IST. All right. So everyone, I'm back. Should we start now? All right. Wonderful. Wonderful. So Roger is suggesting that is anyone interested in getting together a weekday to have study session on Google Hangout? That could be a good idea. I think those who are interested actually can get together, and sometimes this is a good way to have a kind of informal. I mean, studying in a group is generally quite useful and keeps you focused. Okay, so you guys can carry on. I think if you together, if you have more questions, just drop me a message. I can join you if you want. If I don't have any other engagement, but I cannot guarantee. All right. So yes. All right. So Roger, you have the email IDs of people. Okay. And in one of the emails, I had actually put in to everyone. And also on the Facebook group, we have the students group. Okay. Um, and I can add you there. Okay. So everybody is added probably. I think everybody is added on that group.
Yeah, I don't think I'm added on the Facebook group, Sandeep. I
Is
asked
it?
for request. Yeah, I don't think I'm added to the Facebook group.
Okay. Let me just take a look. Why was I locked out? All right. Let me just check if. All right. I just generally just give me a second, and I think that'll be. So we have the members request most likely. Yeah, this is the one. Yeah. Okay. Vikas, is that you? Okay. All right. So I do not know. Is this Stephanie in this session or is from another session? Okay. So Nitesh is from this batch. Yes. Yes. Nitesh is there. Let me approve. Is anybody left? Okay. So feel free to drop a message here. And the problem which I'm facing here is that I'm not able to figure out whether, in some cases, I'm not able to figure out whether they are a student or not. Sometimes, like for example, this one, do not know whether they are our students because their name was not found in our student list. Okay, never mind. So let's carry on our hands-on activity. All right. Okay, so great, great. And yeah, somebody was facing a problem before we uh, so it was yeah, Sunny. It says that Java IO file not found. Yes. Can you do you want to share your screen or how do you want to do? All right, let me stop sharing so that you can share. Yes, go ahead, please. Okay. In couple of such exercises, all of you will be able to move on, and I would not need to do that much hand holding later on. Okay. So yeah, go ahead, Sunny. Please share your screen. All right. So this file, MR examples, how did you produce it? All right. So did you compile it? Does that happen? Okay, using Maven, right? All right. Cool, cool. Okay, so
Actually, I did it in my project in my IntelliJ. I copied it
okay.
directly.
I think I got it. Just run it. Let me take a look at this. Let me
Yeah.
take a look at it. Just run it. Let me check. Yeah. So one is this dot. What is this dot? The output. You're saying input space dot space Java MR out.
If I don't mention dot, it gives me an error saying something.
I get it. I get it. Because you are using an older folder. Because so you are using probably Java 8 in your desktop, and you have compiled it that way. Okay. Can you scroll up? Let me take a look at exact error. Okay. Just a second. Just a second. Um, yeah. Path is not a file. Okay. Path is not a file. So basically, file not found.
I'm using Java 8.
Yeah, so that's the problem. So let's do this. I mean, let's do this. I think we can have one-on-one, because what happens is in your ID, right? You should
Yeah.
generally switch to the Java compiler 7. Okay. The mechanism of argument handling has changed. Okay. Now the
Okay.
argument 0 means the first argument. Argument 1 means the second argument. So argument 0 means the file name as of now. So you might have to use arg1 and arg2 instead of arg0 and arg1. You get my point? Can you show me the code quickly? Can you show me the IntelliJ? So you have only shared the browser, right? You can share the entire desktop. That'll be easier.
I'll just stop sharing and then I will share again.
Yes, yes, that's the right way.
Okay.
So that's yeah. In case we uh, yeah, yes, I can see that now. So go up. So in the driver, go to step driver. Yes, go down, go down. So yes, here, all right, it is actually correct. It is actually correct. Hmm. Okay, I think we should do it on a separate this. You give me the entire log, whatever error log are you getting, and then I'll test it out. Okay. So I think
Sure.
maybe after the session tomorrow or sometime, you send me the log. I'll take a look at it, and I'll try to do it on your behalf in your account, and then I'll get a clear picture. Okay.
Okay.
Yeah.
Thank you.
All right. For now, you can use the same mechanism what we used. I think that one worked.
Yeah, it worked.
Oh, okay, great, great. So I think these
Okay.
are compiler issues. So the general thumb rule is when you're compiling, I mean, to all, this is for all. General thumb rule is when we are compiling, we should keep our compatibility really low. As in, today, even if the Java has moved to Java 9, I compile my code for Java 7 because a code that is compiled for Java 7 can run on Java 8, Java 9, but not the other way. Okay, so that is one thumb rule. All right, great. So let me,
Thank you.
yeah, let's, great, wonderful, wonderful work to all. And is anybody else getting stuck? If we can quickly solve. So who all are able to get the output? Yes. Who all are able to get the output? Mohsin Ghat, Sunesh, April, Srini, Mohit, Samit, Alvin, Pradeep, Vivek, RS, Narendra, George. Awesome. Awesome. What about rest? There are 30 participants. 20 has left. Okay. 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 So Ravi, you can go to Hue and there in your home folder, you will get the output. Okay. You want me to take a look at it? You want to show your screen? Okay. You can show your screen and let me stop sharing and then okay. So Tameka got it. And who else? Yeah. So if you're stuck, just let me know. We can, get it rolling because uh, it it doesn't only teach you MapReduce, it also makes you acquainted with the environment. And 95% of our problems are the environment because rest of the things we can kind of deduce, but this environment issue, if it gets stuck, we don't move ahead at all. So therefore, it's very important to. Okay. So can you open the CloudX Lab? So where is your console? Is it closed or something? Yeah, yeah, this is the one. Okay. So there is a hue. Can you show me hue next to this tab? Next tab. Okay. Click on File Browser on the right top. Right top. Next tab. Next tab. Yes. You see Java MR out. All right. Okay. The other way could be if you go to the console. I think the next to next tab is your console. Next to next tab. Yeah. Okay. It has logged out. If you can log in into console, are you logged in somewhere in the console? This is where you logged in. Okay. Refresh it. Refresh the tab. This is a refresh button in the browser. Yeah. Enter. Paste it. Enter. Then go back to CloudX Lab and copy paste. Yeah. There is the password. Yes. Okay. Yes, that's the tab. Yeah, can you show me? So Hadoop FS, Hadoop space FS space minus ls space Java MR out. No slash, just Java MR out. If you don't provide slash, it looks for the home directory, and inside home directory, you'll find the folder. So you see that? If you want to see what's there inside it, what you can do is instead of ls, you could say cat. You could say Hadoop fs dash cat dash cat cat cat, not get. Yeah, space Java mr out slash slash without space, between no space between slash. Copy the file name like part dash r, that file name you see. Okay, don't press enter unless I tell you. Yeah, now space space pipe pipe, you know the pipe character, the vertical bar just above your enter keyboard, space space more. The pipe more means we want to see the file but page wise. Okay, it's a Unix way of saying page wise. You see more at the bottom, otherwise there'll be a lot of screen blindness. Okay, so the output of the file was given to the pipe and to the more command. All right, good. So yeah, that's it. Great. Anybody else stuck? Anything else? Any other questions, Ravi? Wonderful, wonderful. All right, I'm unsharing your screen. Any other question? A question from Sudhakar: is the data in the output file expected to be sorted? Yes. Generally, the data in the output file is sorted. So I can show you that. The data in the output file is actually sorted, because here it's showing awkward because there's a double quote here in the beginning of the beginning of the character. That's why it looks little awkward, but the output is generally sorted. Okay, good. All right. All right, is any other questions at this point? Yes, Nitesh had one question and I had missed that part. Let me, yes, this is the question I was looking for. Okay, so let me go through. If the input file has two lines, this is a MapReduce class, and I'm enjoying this class. Now, the mapper will have this one, class one, while second mapper will get this one, class one. Okay, let me just think over it. Now the first mapper will give actually, not have, give. Okay, this one is one, map one, reduce one, class one. While second mapper, will give, mm, so, okay, this one and class one. That's right. You are ignoring the rest, non-unique one. Yes. Reducer would get 1 comma 1. This, yes, very good, as input. So it'll be reducer will be called twice. Once for this, other for class. So if so, then merging of the keys is being done by Hadoop itself. Correct. We don't have to do anything. Yes, you are right. Thank you for taking that example. Yeah. Okay. All right. Good. Good. Any other questions? All right. Where is that example, Rahela? Okay. So this is good. And right. So all right. I've tried to keep this thing smaller, and I would like to focus more on Spark. Okay. All right. So this was our MapReduce in Java. Okay. You can create test cases, and you can even create your custom data types. Okay. And yeah, before we jump further, a question from Nitesh. In the last example, only one instance of reduce was called. So in this example, right, reduce function will be called twice, but it'll be a single instance of the reduce object. Okay. It'll be the single reduce of object. In the same case, what we did was, it was only a single reducer. Why? Because we have not specified multiple reducers. If you don't specify multiple reducers, by default, it runs on single reducer. Okay. Did I make sense to you, Nitesh? if we have multiple instances of reduce, how the final result is merged to create a single output file. Good, good. We'll talk about partitioner. So instead of trying to merge the file, okay, the thumb rule is this. Okay, instead of trying to merge the file, we basically plan our records, plan our output such that the two files that are prepared as a result contains mutually exclusive results that can be concatenated. Okay, so if you say cat a comma b, meaning uh, print all the data from a and then b, and still you get the expected result, then you are happy, right? So in the same way, we will basically try to partition the output of mapper to multiple reducers in a way such that the results of the reducer can be concatenated. Okay, you can change, let's say, I will show you something. I'll show you something. So let me try to answer his question, because it's a very important question and lots of people ask this question. Okay, so let's say we are going into Pico. Pico is an editor, text editor, and my and we had stub driver, right? Stub driver, not Pico, Nano. Sorry, Nano. Okay, Nano is the right one. Here, so what you see here is it doesn't have the, okay, let me just pick it from any other file here. Okay, so src, not my sg, so step driver. So there we have yeah, set number of reduced task as 2. So okay, so what we are trying to do is, in our mapper, we are trying to say that the number of reduced task is 2. Okay, the ordering of these things does not matter, by the way, because the job gets submitted at the end of all of it. Okay, so right now we are creating the mapper with 2 reduced tasks. All right, make sense to you? And jar. Okay, it did not compile, or did I do something wrong? Did it really compile? Yeah, it did compile. Oh, actually, yes, I think I got it. If I clean it, then it'll remove. Actually, there were the entire thing was already compiled and kept in another folder. That's why it was taken quickly. Yes, now it's recompiling. Okay, so this is now Hadoop. A quick hack is, if you say Control R, you can search in the history and you will look as if you are really typing fast. Okay, so yes. So I've executed the command again. It says the output directory already exists. Let me just delete Hadoop fs rmr, and let me just delete this. All right. So I'm trying to demonstrate what happens in case of multiple reducers. Okay, so we have set reduce task as 2. Okay, Okay, so now let's take a look at my files. And if you go to my home folder and you sort the data by the date, okay, you see here, you see these two files this time, Nitesh. And now what you see here is, so there is some records here, okay, some records here. I'll just make two files like this, okay, and put them side by side. And we have some records in another. Now, if you take a look at this file, right? If you take a look at this file, these, oh, I've actually copied the same data twice. How come? Yeah, this is the one. So, all right. So these are the two parts. This one is the first one. Now, individuals' data is actually sorted. If you see, this one is itself sorted, but this one is also sorted. Correct? But they are overlapping ranges. They are overlapping ranges, right? I mean, if you see A, double quote A has gone here, double quote A dash TU has gone there, and so on, right? These are overlapping ranges. And the problem with this is that it's difficult to merge these kind of things. So instead of this way, right now what's happening is first line is going to first word is going to first reducer, second is going to second, third is going back to the first one, the fourth is going to the second one, and there's a round robin thing happening. You remember our mapper where we were talking about partitioner? Based on the key, it computes the number divided by 2, and if it's odd, it goes to the first one, first reducer. If it's even, it goes to the second one. It's as simple as that. Now, we could change that logic. We could change that logic. Okay, that's called partitioner. Okay, that's called partitioner. We will talk about partitioner in a point after some time. Okay. Okay, a question from Narendra. Do we need to know where these two tasks ran? That is, which nodes? We don't generally need it, but if you want it, you can take a look at the job browser. I forgot to tell you this. So let me explain again. So here what you see is I have executed word count twice, earlier at this time, now at this time, okay, after 1 hour. So this is the most recent one. The time is in UTC. Okay, it says that for this job, there were these many tasks that got created. There was one mapper and there were two reducers. Okay, for each of the tasks, it has number of attempts. How many attempts were there? There was only one attempt and it succeeded. And it shows that where was this particular attempt executed? You see, it was executed at this particular machine. Okay, and whatever output you print, if you see my code, I have printed some data records. All of that is printed here. The output is printed in the logs. All right. Okay, so you can click on the logs and take a look at the logs. For some reason, it's taking too much time. All right. So, yeah. So most of these problems that you can take a look at the logs and debug your MapReduce job. Okay. So one way it could be that you give. So I'm trying to still answer the same question. that if you have multiple files as a result of reducer, what can you do to merge? That's the first thing. Okay, let me restructure it. Okay, first thing you can do is in the next Hadoop job, you can input the folder. Okay, Java MR out as input. Okay, so one is that if your job is okay with this kind of ordered data, okay, if you want concatenation, you want the data to be strictly sorted, you may want to make sure that there are no overlapping ranges, okay, by using partitioner. Okay, by using partitioner. All right, so you can see stdr logs. So yeah, so here this is the log of this. If you print something sys out, this is where it will come. Okay, all right, good. Now moving ahead, and a question was there that how do you check the logs from the console? I think there's a command which Hadoop provides. There's a Hadoop way of showing the log. There is a command for doing that. I have never used it that way. So ideally what we used to do is if we are running a Hadoop job, we will generally run via submitting the job either via cron or from some other way, and it will save the log to it'll basically save the log somewhere, and we will collect the log from all the nodes to a central place. Okay. I mean that's anyway in HDFS, and that's how it is. Okay. Mutual. Naren is saying that so with partitioner, the data is handled mutually exclusive. No, actually, you have to plan your partitioner such that your data becomes mutually exclusive. Saying all the words starting with A go to reducer one, all the words starting with B go to second, and so on. That's mutual exclusive. Okay. The default partitioner, which is there, it's using a different way. Nitesh, was I able to answer your question? No? All right. Good. Great set of questions. All right. Now that was our, all right. So basically, there are a few things which are important. So, I mean, if you want to get into Java MapReduce, then you may want to understand how to create your own objects which can be written to. Okay, just like long writable, int writable text, and so on. Now, this is more important. Okay, so in case you want to read file from your mapper directly from HDFS, you can also do that other than taking that input. Okay, all right. So you can also customize input split and input format. If you want to create your own input format, you can do that. Let's first try to understand. We will talk about input splits later, but you can customize your input split if you want. Okay. All right. So instead of going into advanced side, I would love to do a little bit more hands-on. Okay. All right. I think instead of jumping into advanced side, I will go with now Hadoop streaming. Okay. So far, the people who are not from Java background, they really felt out of place. Okay, they really felt out of place, and that's where the role of streaming comes into play. Okay, the streaming is a very badly used or very misused word. It is when you're watching a movie, that's also streaming. When we said SED, that's a streaming editor which processes the input stream. And when we talk about processing data continuously as a daemon process or as a background process, that's also called streaming. So there are various ways where the streaming word is used or misused. Okay, here we are using streaming means data from one command is going to another command. Okay, that's the streaming here. The way SED was doing the job, right? You remember our Unix command example where we were passing one command's output to another and so on. Hadoop MapReduce makes that possible. Okay, so Hadoop streaming job is basically a Hadoop library, which makes it possible to use any binary or any program as mapper or reducer. Mapper gives out key tab value one per line. Okay. The only contract which mapper and reducer has to abide by this any program, all they have to abide by is they have to give out the result in the form of key value which are tab separated. Okay, and reducer gets ungrouped data. That's one thing that is different from rest of the MapReduce. Here, streaming guys, what they do is they ungroup the data. So your reducer actually gets sorted data instead of grouped data. Okay, your reducer gets ungrouped data. Okay, so mapper is a command, reducer is a command. Mapper takes data from standard input and converts that into key tab value. And reducer is also a command which gets the data in the standard input, and it basically gets the data which is ordered. So what you can think of Hadoop streaming job is that Hadoop streaming job is kind of a replacement of the sort command. It sorts the data given out by the mapper and gives the output to the reducer. Okay, so what you see here is an interesting thing. Here we are saying Hadoop jar and then this command dash input and then this and output is this. Okay, let me take this out, make it a little more humane. Okay, all right, closing this, and also there's no need of this. Okay, so what you see is interesting part here. There is this jar, right? In the previous program, we had written our own jar, right? Emma.jar was generated because of compilation, right? So somebody wrote this nice jar called Hadoop streaming so that we don't have to write the Java code too much. Okay. In case you are in your Hadoop at somewhere else, you can find out where is this jar located. Note that this jar is located in the local file system, while the input folder and output folder is located in the HDFS. Okay. So let's take a look at how to find out. So a quick way is find slash name and give the name of the file. Okay. And then you also say dev null. Okay. Why I'm saying it? So that all the error messages, they are sent to the null. All right. So it's basically trying to scan through the entire file system, and then it'll give you the location where it finds the streaming jar. Okay, so at any point you can use this command to locate where is the staging jar. Here we knew. Okay, so although generally there are installation specific locations and all, but I find finding to be the more intuitive way. Or the other thing we could do is here, we could also say things like this. Okay, a string. That will also work. All right. So yes. So that's one way. Now, coming back to it, so there is this program, there's a MapReduce under the hood. It's a MapReduce Java, written in Java, which makes it possible to use any program as your mapper and reduce as any program as reducer. Only contract they have to abide by is the mapper should give out key value pairs, tab separated, and reducer should give out values tab separated. The tab can be customized. You can have some other special character. Okay, so here we go. All right, now then comes the input. This is the input folder, then the output folder, then the mapper. So you can see that we have to provide the input path, output path, and the mapper here is SCD command. You remember our SCD from previous, where we were basically replacing spaces with the new line, right? And then reducer is this. So all we have to do is just copy it to our home folder, and that's it. Okay, let me try to run the command. Sorry, I think I sent it to Rahela. Okay. It says the output folder exists, so we can simply delete it. Could say Hadoop fs rmr and delete the folder. Okay, now let me try to execute it again. Okay, so what does it say? It says some error which is occurring here, maybe some problem with the node. We'll try again somewhere else. So reduce gave an error. Okay, map job gave an error. But it got executed on some other machine here. Okay, and it has created this folder, output folder. Okay, so is everybody able to execute it? So you can see that word count we have just written in a single command. All right. We did not have to write a single line of code. We just exploited our knowledge of Unix. So this is what is happening under the hood. For each input line, each input data is being passed through our SCD command. What it does is it basically equivalent is this command is basically equivalent of Control F in your text editor, like Notepad or WordPad. This is basically equivalent to Control F in those places where we are trying to replace space with a new line, and then it basically converts this into this vertical. And you notice that we have not given any value. Okay, and this is very legal. If you don't provide tab, the entire thing is considered as the key, and there is value is null. If you provide multiple tabs, the rest of the tabs are become part of the value, because before first tab everything is a key. Okay, and then this one is sorted. You see the dash line? It is the job of Hadoop. It's basically ordering this data. So it became ga, re, sa, sa instead of unordered. And then unique minus C was executed on this section of the data, and then we get the results. Yes? So this is the only part that's being executed. This is the work that's being done by Hadoop. Yes? All right. Good, good. So is everybody with me? In the same way, uh, while sending the output, it'll make sure the same key does not go to multiple machines. Meaning Sa and Sa both have gone to the same machine. It would never happen that Sa went here as well as here. Okay, that's how the default partitioner is designed. Okay, sometimes what happens is the program that you are trying to execute, we were happy just now because unique and SED, both commands were already installed on all the machines. Both commands, SED as well as UNIQ, these two commands were already installed on all the machines. Therefore, we did not have to install it again. We did not have to install these two commands again, but sometimes that command may not be there. For example, let's say that we want to do cleanup here. We want to do cleanup here. Okay. So what we do is, so we write this part into the one text file, say mycmd.sh. Okay. Pay attention, please. So I'm trying to do is, oh, it logged out. Why did it log out? Is my connection flaky maybe? Okay, so here what I'm trying to show you is sometimes the program, let's say you want to make a shell script. This is my shell script. Sorry for Pico, it is supposed to be Nano. Okay, so here I've written a shell script. What it does is whatever input it gets, it replaces spaces or white space with a new line. Then it removes all the non-alphanumeric characters, and then it translates it into lowercase. Okay, so that's the next command. All right, that is the next command. So you can also create it. I've pasted the content in the chat. Okay, and then once you're done, you can execute this command. Okay, let me just clean it up, and that's it. So I'm trying to make it in a single line because the whole command has to be in a single line, or it should be. Okay, there we go. So all right, so here we are saying that this is same. This is same. We are saying we are saying this is streaming jar. Here we are also saying that use to reduce tasks. Okay, this is our input folder. This is our output folder, and this is our mapper. Okay, this is our mapper command, and here there is extra arguments called file. It means install mycmd.sh or copy mycmd.sh on that local machine. Okay, but keep in mind, before sending this command to Hadoop, you should make it executable. So you should make it executable. Okay. All right. Actually, it has come out pretty bad. Let me just try to fix it. Okay. So here we go. Nano mycmd.sh. Then put this command inside this, and then okay, press Control X, and after that execute this command. Okay, I'm saying clean underscore out. This time we are trying to clean this. Okay, so using Nano, we are first trying to create the file. Okay, when the Nano comes up, copy paste this part and then save it. Okay, Control X and Y. Okay, and then change the permission because you have to make something executable, and then you execute this command. Okay, that's it. All right. So we did nanosmycmd.sh. We have already written this script. Then we've already copy pasted, finished this work. Then chmod this, meaning make my command executable. And then we are executing our Hadoop. Okay. Yes. Is everybody clear about what we are trying to do? Yes. The first command is still executing. Yes. It might take a little more time. Okay. All right. So what you're going to see is the output inside Hadoop, fs, ls, not ls, cat, part, star, mode. So you can see the output is very clean. See? Okay. Also, somebody was asking this before in the discussion, can we bring the number to be formatting? This has done formatting pretty well. Okay. I don't know which output format are they using. Yeah. You can see the counts and yeah, and the data is very clean. All right. Now, if you want to order this data by say numbers, you may want to create your own MapReduce job again, and then feed this data to that, and then order it by the key. Okay. But for time being, what I can do is I can use my sort command, which is offline, right? And can sort the results. So you can see that the is the most commonly used word. And after that, all of these are very commonly used words. You can see that. And the prince is one striking word, which is so common. Pierre is strangely many times, occurring many times, and so on. All right. All right. So I hope I have been able to explain the streaming job. Okay. What was the command for clean? Clean as in uh, there was one was ant space clean, and that was to clean up the Java workspace. All right. So take your time, try executing whatever we have done today, try finishing that and drop me an email if the things do not work. Okay. So drop me an email at support at no big data. Okay. Support at no big data. Okay. And let me know if you are not able to do it. So assignment for all of you till tomorrow is whatever we have done today, do it by yourself and do it, and try to execute these commands with multiple reducers, with try executing other examples as well. Okay. All right. Alvin, April, George, Giancon, Kar, Krishna, Mohit, Mohsin, Narendra, Nitesh, Ravi, Roger, Sudhakar, Shamit, Hang, Mahmood, Pradeep, Rahila, Shunesh, Srini, RS, Tameka, Tegusrini, and Sunny and Vikas. All right. The agenda for tomorrow is that we are most likely going to start with pig and hive. Okay. So most likely we'll finish pig tomorrow, along with whatever is remaining out of MapReduce. Okay. Will you provide the notes on the Google Drive? Okay. Notes on Google Drive, and the other thing I had to provide was rearrange the slides for session according to session sync, basically sync the slides. Okay, according to sessions. All right. All right. So try executing this. Try writing. I would say that if you are okay with Java, try writing your MR job, which cleans the data and executes it. Okay. See you tomorrow, and I look forward to see you. Okay. 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 So yeah, I think one of us have removed the advanced MapReduce slides. I'll put it back. Okay. See you tomorrow. I look forward to see you. Bye-bye. Yes, Ravi, you can download all the recordings anytime later. You can use a YouTube downloader as well. There are many YouTube downloaders. We don't have a problem if you download, honestly. Okay. Because what we realize is a lot of people travel and they want to watch the video and want to keep it on the tab and would like to go through a particular concept quickly. In those cases, you may want to have the videos with you. So feel free to download and keep with you. Okay. All right. Bye bye. Have a good day.